This video will demonstrate how to make Cubeoctahedra using magnetic or buckyballs. Now, a cubeoctahedron is essentially what you get when you take a cube, so 6 squares, and octahedron, 8 equilateral triangles. Take the surfaces and mesh them into one solid, and that's what you get here. And I have the two different sizes here, one that has 3 as the length and one that has 4, and those are the n in this equation, which tells you how many magnetic balls are needed to make the figure. An interesting note about this is that you could, in theory, make the n equals 1, n equals 2, n equals 3, and n equals 4 octahedra and out of a set of 216 magnetic balls, which is what you get with a 6x6x6 set. So first, let's dismantle these in order to show how to make them. Making a coil so it's easier to work with. Now I'm going to make both side by side, the n equals 3 and n equals 4. The n equals 1 is trivial, it's just one ball, and the n equals 2 is impractical. So I can sometimes get the top layer on, but when I get to make the other one, it's something about the forces makes it fall apart. So that's why I said in theory you could use the right number of magnetic balls. So, but both of these figures start out the same. You take 6 balls to make a hexagon and you wrap around them. For the n equals 3 scenario, you only wrap around once. And you fill it in. For the n equals 4 scenario, you wrap around twice. I'm going to wrap around before I fill it in, just in case the ball in the middle doesn't have a chance to throw off the forces for other balls and lose its shape. So here we have the startings for both the n equals 3 and n equals 4 cubeoctahedron. For the next layer, for both of them, we start with 3. Squished into a triangle and then wrapped around. Again, you'll wrap once for the n equals 3. Start with 3. You'll wrap twice for the n equals 4. So there's one wrap. And here's the other wrap. Now, I'm going to need 2 for each, so I'll just make another set right now. Start with 3, wrap around once. Start with 3, wrap around twice. First wrap, off a little bit, try that again. One wrap, and second wrap. All right. I'll demonstrate this with a larger one because it's a little easier to see, but I want it to interlock instead of be straight on when I fold it over. You'll notice that I've got interlocking on one side and straight on the other. And it alternates, interlocking, straight on, interlocking, straight on. And for the other side, I want to do an offset. So instead of straight on like it is right here, I turn it over, because when I have it straight on up above here, I want it interlocking down here. You'll see that each side switches in a similar fashion. So that's the beginnings of the n equals 4 cubeoctahedron. This also needs to be, let's see, squish that in a little better. Needs to be interlocking. So here we go. Okay. And just like with the n equals 4, I want it to be alternating. The straight on and, well, not alternating, but opposite the top. So here we have it lined up, and down below we want it to be interlocking for the same side. This one's interlocking, this is straight on, interlocking, interlocking, straight on. So I have the beginnings of both. This requires one more layer, this requires 2 in order to finish this triangle. So to continue, I need 2 on one side, 4 on the other. That's easy to obtain using, starting with 6, pushed into a triangle, and then wrapped around once. And I need 2 of those. So again, start with 6, push into a triangle, wrap around once. Okay, it needs to be interlocking, and it should just fold down on top. And then I do the same on the other side. Interlocking, it's not, so I need to turn it around. There we go. And it should just fold down. Okay, and the last that I need on this side is a triangle, and it's going to have a length of 4 with just a tip. So I need 4, 3, 2 in my triangle. So 4, 3, 2. And I want it to be interlocking when I lay it down. So here we go. That's right. And then I squish it into a triangle. And I also had to offset it a little bit. And I need to fill it in finally. So that completes that side, and we'll do the other. So another 4, 3, 2. Snap together. Need it interlocking. This is straight on, so let's turn it around. Much better. Okay, form a triangle. Okay. Now fill one in. Oops. Alright, that completes that figure. And the other one's going to need a triangle of length 3. So that requires 3, 2, 1. It also needs to offset when I fold it over, and then squish it together into a triangle. Okay, no need to fill anything in, it's already done. And I need another 3, 2, 1. 3, 2, 1. This is straight on, not interlocking, so I'll turn it around. Okay, now it should work. fold it over, and then squish together into a triangle. And that gives me the n equals 3 and n equals 4 cubeoctahedron. And as I said before, there's 14 magnetic balls left over from a set of 216. So thank you for watching.